Good morning, viewers. This is Kasturi Day. Today, am going to start with the postulates of atomic model, as I discussed in my last video. I told you I'll explain these postulates of this atomic model of Rutherford. Okay, I'll start with that. And along with it, I'll also discuss the postulates of Bohr's theory. Okay, Bohr's atomic model. So I'll discuss these two. Some other slides may also be there. So please, for that reason, you have to please stay tuned with me. Okay, and do subscribe my channel and also ring the notification bell, because as soon as a new video is uploaded, it will give you a notification. Okay. And if you're liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to start with the meditation when you start your day. Okay. So for meditation, let us concentrate on a point of light just for 1 minute, and then we will start with the discussion for today. Okay. So think of a point of light. Think that light is giving you rays, and that those rays are reaching you. They are reaching your whole body, is being lightened up through those rays. You're getting energy, fully energized, you're becoming fully energized. You feel like everything what you want to do in a very short span of time. Okay? You're getting interest in what you're doing. You're happy in doing what you're doing. You're enjoying those things, what you're doing. And finally, you're becoming successful. You're getting good results. This might is a great benefit for you. Listen from here. So at the same time, let's start with the discussion. So in my last video, I told you about the atomic model which was given by Rutherford. Okay. So Rutherford, along with Madsen and Geiger, he bombarded a thin sheet of gold of 100 nanometer thickness with alpha particles, which was emitted by radium. And he saw that the alpha particles, after an interaction with the thin sheet of gold, they deflected. Okay. Then when these alpha particles were allowed to fall on a zinc sulfate screen, okay, and that produced some fluorescence. Okay. Now, which deflected the deflection. Okay. Counted this the how many sparks were given by these alpha particles on a zinc sulfate screen, which detected the deflection. How many deflection was there? That was detected by how many sparks which produced by the alpha particles. Okay. Now, from this conclusion, almost all the atomic matter was concentrated in a tiny volume which is at the center of the atom, and that is known as the nucleus of the atom, or atomic nucleus. Okay, and this atomic nucleus, we will see that due to this atomic nucleus, some of the alpha particles that were deflected back by large angles, or by 180 degrees, it deflected. Okay, very few of them they scattered by small angles, or major fractions they did not deflect at all. Okay, so this was given by Lord Rutherford along with Marsden and Geiger. Okay, so this was this gold foil experiment, and now we are moving up to the postulates of the atomic model. Now, According to him, according to his postulates, an atom is composed of positively charged particles. Okay, majority of the mass of the atom was concentrated in a very small region, which was known as the nucleus of an atom. Okay, so the nucleus of the atom is the densest part of the atom. Okay, and it is composed mainly of positive charged particles. Okay, and majority of the mass is inside the nucleus. Okay, the nucleus is electrically positive as the positively charged alpha particles approaching the nucleus gets deflected, proving that the nucleus contains protons or positively charged particles. Okay, so according to him, the nucleus, as the nucleus is the densest part, it has the major mass of the atom is concentrated inside the nucleus. Okay, and it has some positively charged particles inside it. Okay, and this has been proved by when the alpha particles hit the nucleus, it got deflected. Okay, because we know that same charge uh, they deflect each other. They reflect back. Okay, so that's why the alpha particles which were positively charged, they did not attract, but they deflected from the positively charged nucleus of the atom. So this proved that the nucleus contains some positively charged particles, which we name as protons. Okay, which was named as protons. Now, atom's nucleus is surrounded by some negatively charged particles, which were known as electrons, which revolved around the nucleus in a fixed circular paths, and these circular paths are known as orbits at very high speed. Okay, like the solar system, no, the sun, imagine that the sun is the nucleus of the atom, and the planets which are revolving around the sun, these planets are imagined to be compared to the electrons, which the negatively charged particles which revolve around the nucleus. Okay, so at very high speed. Now, the force of attraction between the negatively charged electrons and the positively charged nucleus is counterbalanced. Okay, the force of this attraction is counterbalanced by what force? By a centrifugal force, which is acquired by the revolving electrons. When the electrons are revolving around the nucleus, so they acquire some centrifugal force. Okay, and this force balance the force of attraction between the negatively charged electrons and the positively charged nucleus. Here, now this is a strong electrostatic force of attraction that holds the nucleus and electrons together. This centrifugal force is a very strong electrostatic force of attraction that holds the electrons and the nucleus together. Okay. Inside the atom. Otherwise, the electrons would have been flown away from the nucleus. Then an atom has no net charge because it's electrically neutral. Why? Because the total negative charge of the electrons is balanced. The total negative charge of the electrons are balanced by the total positive charge of the nucleus. That is, negative charge is equal to positive charge. Okay, quantity of negative charge is equal to quantity of the positive charge, and that's why the atom becomes electrically neutral. Now, the size of the nucleus of an atom is very small in comparison to the total size of the atom. Okay. The size of the nucleus is very small. Nucleus of an atom is very complex, very small in comparison to the total size of the atom. This has been proved by the fact that most of the alpha particles, they pass straight through the gold foil without being deflected. That's why there may be some empty space. Okay, the space is much more than the nucleus which is at the center. Okay, that's why the alpha particle did not hit anything and they pass like that. Okay. Now, besides these, the atom also contains, I told you, some extra nucleus space or large empty space is there. Due to this space, most alpha particles, they pass through the alpha metal foil without deviating from their path. Now, his atomic structure is similar to the structure of the solar system. I told you the sun is at the center and planets are revolving around it. Like that, the nucleus is at the center and the electrons are revolving around its orbits. Okay. This is the picture of Rutherford's atomic model, and this is the solar system. You can see this may be compared to the sun, the nucleus, and these are the electrons which are revolving around the nucleus like the planets of the solar system in their orbits. See, this is the planets, this is the sun at the center, and the planets are revolving around it. Like that, this is the nucleus, and the electrons are moving around, revolving around the nucleus. Now, we see that this Rutherford's atomic model, this has some drawbacks, some limitations are there. Okay, some things which are not clear in this Rutherford's atomic model. Okay, so what are those? Rutherford's model of an atom could not explain the stability of the atom. He could not explain how much the atom is stable or not. According to him, charged electrons revolve around the atom in the circular path. So it should be experiencing acceleration, due to which it should lose energy continuously in the form of electromagnetic radiations and then eventually fall into the nucleus, thereby making the atom unstable. Okay, according to Hume, what did he tell? That it is moving, the electrons are moving around the nucleus, okay, and they are moving in a circular path, and thereby it is experiencing some acceleration, okay, acceleration, and due to which, when it is experiencing some acceleration, it is losing some energy. So when it is losing energy, the electron, when it is losing energy, at that time, what happens? Due to the electromagnetic radiations, it is losing energy. So when it is losing energy, so it will slow down and come closer to the nucleus, and eventually it will fall into the nucleus, thereby making the atom unstable, because the charge, positive charge, will be known as electron as it is moving and getting inside the nucleus. So that will create a more positive charge than the electrons, and the count also will become unstable. Okay. The Rutherford's atomic model of an atom could not explain as to how the electrons are arranged in the orbits around the nucleus. He also was not able to explain how the electrons were arranged in the orbits around the nucleus. How were they arranged? Okay. So now, for this, as there were some drawbacks in Rutherford's atomic model, so Bohr, Niels Bohr, he was a Danish physicist. He proposed a model of the atom in 1913. Okay, to clarify these drawbacks, to do away with these drawbacks. Okay, so it came into existence. This Bohr's atomic model came into existence with the modification of Rutherford's model of an atom. Rutherford's model introduced the nuclear model of an atom, in which he explained the nucleus is positively charged and is surrounded by negatively charged electrons. But Bohr's theory modified the atomic structure model by explaining that electrons move in the fixed orbitals or shells and not anywhere in between. Okay. So Rutherford, he said that nucleus is positive charge, is at the center, and electrons is moving surrounding itself. Okay, and he also told that it is that while it is moving, it loses its energy and all those. But Bohr, he said that he modified this structure, and he said that electrons, they move around this nucleus, but they move in a fixed shell and not in anywhere in the between. He also explained that each orbit or shell, they has a fixed energy, not that the electron has the fixed energy. The electron has the energy which it loses as it moves around continuously around the nucleus. But it has the orbit, the particular orbit on which the electron is moving, that has a fixed energy. Therefore, Rutherford explained the nucleus of an atom, whereas Bohr modified that model into electrons and their energy levels. Clear? Next is, we are coming to the postulates of Bohr's model of an atom. So what did Bohr give? What postulates did Bohr gave? Okay? The negatively charged electrons in an atom, they revolve around the positively charged nucleus in definite circular paths which are known as orbits or shells. Okay? Each orbit or shell has a fixed energy, and these circular orbits are the energy levels which are named by him. Okay? The energy levels are represented by an integer, that is n, which means 1, 2, 3, etc., known as quantum number. The range of quantum numbers starts from nucleus side with n is equal to 1, having the lowest energy level. The orbit n is equal to 1, 2, 3, or 4 are assigned as the K, L, M, N shells. And when the electron attains the lowest energy level, it is said to be in the ground state. Okay, so what happens? The energy levels, I told you, they have these orbits, they are known as energy levels by him, by Bohr. Okay, and they have a fixed energy. Each shell has a fixed energy. Each orbit has a cell or a shell that has a fixed energy. And these circular orbits, they are known as energy levels by him. Okay? And the energy levels are represented by an integer, like n is equal to 1 or 2 or 3, like that, and which are known as quantum number. This range of quantum number starts from the nucleus side, towards the away from the nucleus. So starts from 1, which is close. I mean, the energy level is equal to 1 when it is towards the nucleus, then it comes 2, then 3, then 4, like that. Okay? So, and this energy levels, these orbits, these energy levels are named as K shell, then L, then M, then N, like that. Okay? When an electron attains the lowest energy level, that means that shell, that orbit is close to the nucleus. And that state, when it is of the lowest energy level, that state of the electron is in the ground state. Okay. Now, the electrons in an atom, they move from a lower energy level to a higher energy level by gaining a required energy, and an electron moves from a higher energy level to lower energy level by losing energy. So when an electron of an atom, they move from this, say, suppose from K to L, it has to move. So from K to L, when it is moving, it is gaining energy. And from L to K, if it is returning back, then it has to lose energy. Okay? Now, but while it is revolving around the nucleus in an orbit, it is neither gains nor loses energy. So when it is moving in its particular orbit, it's not moving from one energy level to another energy level, then it will not gain or lose energy. Only it will lose or gain energy when it is transforming from one energy level to another energy level. These are the energy levels you can see. This is the nucleus, and this K shell is close to the nucleus, or one energy level that is close to the nucleus. Then comes 2, 3, 4, like that, K, L, M, N. Clear? Next, we come to discovery of neutrons. So we know that electrons have been discovered, protons have been discovered. Now we come to the discovery of neutrons. As it is known that an atom contains electrons and protons, and an atomic mass of electron is negligible, then whereas the mass of proton is 1 AMU. Okay, so it is known that the atom contains what? Electrons and protons. We know. Now, by now we have been knowing that electrons and protons are the things which are subatomic particles which are present in an atom. Okay. And also we know that the atomic mass of an electron is negligible. It's very less. But the proton mass is 1 AMU. Clear? Now, as an atom of helium contains 2 protons, as an helium atom contains 2 protons, the mass should be 2 into 1, that is 2 AMU. 1 proton, 1 AMU. Therefore, 2 protons, 2 AMU. But the atomic mass of helium was found to be approximately 4 AMU. How is it possible? Okay, so it was proposed that there is another subatomic particles in the nucleus of an atom which should not possess any electric charge but has a mass which is almost equal to that of proton. Okay, so from this concept that as helium is having 2 protons, it should have a mass of 2 mu, but it is found that it is approximately 4 A. The mass is coming to be approximately 4 A. Then what happens? Then there must be this concept, this conclusion. From this, it has been concluded that there must be another subatomic particle which is present in the nucleus, which has a mass which is almost equal to that of the proton, but it has no charge, no electric charge. Now, later in 1932, a British physicist, Sir James Chadwick, he discovered this neutron. What did he do? He fired alpha radiations at beryllium sheet. He used a beryllium sheet here from a polonium source, and from that he fired alpha radiations. So he took a beryllium sheet, and from polonium source he fired alpha radiations, which led to the production of an uncharged penetrating radiation, which produced a radiation which was uncharged and penetrating. Okay. Now, this radiation was from polonium source, the alpha radiation which came out. This radiation was made incident of the paraffin wax. What is a paraffin wax? It's a hydrocarbon which has high hydrogen content. The hydrocarbon, and which is having a high hydrogen content. It's a paraffin wax, and this radiation was made to fall on that paraffin wax. And when it fell, when this radiation fell on the paraffin wax, or this incident of the paraffin wax, it led to the production, or it led to the ejection of protons from this paraffin wax. Okay, with the help of an ionization chamber. Okay, he made an ionization chamber. He left the paraffin wax there, which is a hydrocarbon having hydrogen content, more of hydrogen content, high hydrogen content. Paraffin wax is there. And on this paraffin wax, this radiation was allowed to fall. And when the radiation fell, paraffin wax started ejecting out protons. Okay. Now, then the range of liberated protons was measured. How many protons was being liberated? That range was measured. And the interaction between uncharged radiations and atoms of several gases was studied. Okay, the interaction between the uncharged radiation and the atoms of the several gases was studied. So, this was done. Okay. Now, from this, see, this is the picture from of this one of James Chadwick, which he used, the instrument which he used. This was the paraffin wax. In the ionization chamber, he used this paraffin wax. This is the beryllium sheet and polonium source. From this polonium source, he bombarded this beryllium sheet, which produced some radiations, which was allowed to fall in this paraffin wax, and the paraffin wax started emitting protons, which was introduced inside the ionization chamber. Okay, and the behavior of the several gases was studied, where the uncharged radiations and the atoms were studied. Okay, now from this he concluded that unusual the unusually penetrating radiations consisted of uncharged particles. Okay, so he concluded that the unusually penetrating radiations which he found the radiation that consisted of some uncharged particles which was having approximately the same mass as that of the proton. Okay, and which he later named as neutrons. Okay. See, this is the equation. What happened? This beryllium. Okay, this when helium, this alpha particles were used on this beryllium sheet, then it's bombarded with it, then it emitted, and it fell on this paraffin wax, which is carbon, that is hydrogen carbon. Hydrocarbon is there, so it produced some carbon and some neutrons. Okay, so a neutron is what is then a neutron is? It is also a subatomic particle or fundamental particle of an atom, which has no charge but mass almost equal to the mass of the proton or hydrogen atom. Okay, it is denoted by N01. Subscript is 0, that is no charge, and mass is 1. Mass is 1, so that is 0, 1. Okay. Now the superscript 1 represents its mass and subscript 0 represents its electric charge. Here, next we move on to the properties of neutron. What are the properties of neutron? Neutrons are the constituent particles of all nuclei except hydrogen, because hydrogen has only protons, no neutrons. So neutrons are the constant particles of all nuclei except hydrogen. They are neutral particles having no charge and mass is slightly greater than that of the proton. That is 1.676 in 10 to the power minus 24. Okay, and hence they are not deflected as they have no charge, so they are not deflected by electric or magnetic fields. They are stable inside the nucleus, but outside the nucleus they are unstable. When they are inside the nucleus, they are stable, but when they are outside the nucleus, they are unstable. The free neutron, when they are coming outside the nucleus, they are unstable. This free neutron decays with an emission of proton, electron, and anti-neutrino with a half-life of 13 minutes. Okay? So this neutron, it breaks down, it emits, decays, and it emits hydrogen, that is proton, and electron with a half-life of 13 minutes. So I think I'll stop here. I'll continue with this atomic structure in my next video. Okay. So till then, please go through this. If you have any doubt, please write in the comment box. If you have any, you can also refer to my email ID, that is kasturi74@gmail.com. Okay, and please to subscribe my channel. And also ring the notification bell, because as soon as a new video is uploaded, it will notify you. Okay, and if you have already subscribed, so you can press the like button, share with your friends. Okay, and also do meditate before you start your day. Okay, so thank you for joining and have a good day.